Welcome to another lesson. For today, the lesson we are going to look at is actually related to other topics that we have discussed before, because even what we are going to start today is a two-dimensional study of vectors. And so vectors can be studied in one dimension as well as two dimensions. And so for today, we are going to look at vectors in two dimensions. This is a very important lesson because it helps us to actually apply these concepts to when we are dealing with forces which are radiating from probably one point, and maybe there are several of them, so we want to get a resultant force, or even in momentum, where probably there are several momentum oriented at different angles. Therefore, we want to find a single momentum that is after resolving the momentum in different orientations. And so this is a very basic concept that learners should understand even before they study other complex physics problems that require the use of the understanding of vector quantities. And therefore, I'll apply this to a very simple question that I feel once the learners have developed concepts in this area, they can apply them into many other complex physics problems. And there we go. So what are vectors? Vectors are actually, in physics, we can define them as quantities that have both magnitude and direction. In other words, what we are saying is that a vector quantity should have size as well as direction. In other words, we can say maybe if it's a force, it should have some newtons as well as the angle at which this force is oriented. Unlike other quantities like scalar quantities, which are only defined by the magnitude. And so, but today we are concentrating on actually vectors. And so it's important that we have concepts relating to the addition of vectors oriented at different angles. I've given a diagram here showing forces, which are actually about 5 of them. There is force A, force B, force C, force D, and force E. Force A, it is actually 7 newtons, and the angle of the x-axis is 33 degrees. Force B is 10 newtons, and also it has an angle 2, which is 29 degrees. Then force C is 12 newtons, and it has an angle which is 35 degrees. And force D is actually along the y-axis and is 6 newtons. Force E is 9 newtons along the negative x-axis. And so we have to resolve these forces so that we have a single force through which all these forces can pull through. And to do this, we need to have basic concepts of resolving forces into components. And so the first part of the exercise is to resolve these forces into the x component forces. So I've given an example of force A, how we can resolve it. You actually draw a triangle. This is the force A. And so for you to resolve it in components and it has an angle of theta, you say this along the positive x-axis is force A cos theta, and while this one is force Y sine theta. And you note that this force is going along the positive x-axis is positive, as well as this one is along the positive y-axis. It is actually positive. And so when you actually substitute what is given there, you find that for number one, force A would be actually 7 times cos 33, which is 5.87, and it's positive. For that is resolving it into the x-axis. All this, what we're doing now, is to resolve all the forces into the x-axis. It's a basic concept, but it's very important for us because it has an application in future where we'll have to apply it. Force B is equal to B, force B times cos theta, which is 10 times cos 29, which is 8.75 newtons. Again, we can resolve force C. Force C, actually, this is the force, which is this one here. Now, to resolve this one, you note that it will be along the negative x-axis. And so, each time we are resolving all these forces, there are two methodologies you can use. One way is that all the angles, you can actually count them, starting from the positive x-axis, going anti-clockwise like that. And you notice that this force here, it will go around until you reach E here, which is 180 degrees. And therefore, for C, we can say up to where it is actually 35, meaning that you have to add this 180 plus 35, and it gives us, for us to reach this point here, it gives us 215. It gives us actually 215. So it will be 12 times cos 215, which is the same as merely multiplying cos 35, that angle, and you put a negative, since you already know that it's oriented along the x-axis. It gives us negative 9.83 Newton. For force D, we note that it's along the positive y-axis, and therefore the angle starting from the positive x-axis, if you go there, this is actually 90 degrees. And so we know that 90 degrees cos 90 is actually 0. And therefore you can say 60 times cos 90 is 0. Meaning that this force D has no component in the x-axis. And similarly, for force 5, force number 5, which is force E, you notice that is oriented along the x-axis, and therefore this one is negative. So this force, you can merely multiply E times cos theta, which is 180, and you know that cos 180 is negative 1, and therefore 9 times cos 180, which is negative 9 newtons. So it means that we have developed here the concept of resolving forces in the x components. So let's again learn now how to resolve forces in the y component. We do the same. The only difference is that now we're going to have sign. The angles will be the same, but all of them. So we can say A cos theta, which is 7 times sine 33, which gives us 3.81 newtons. This one will be positive. Then for force B, it will be 10 sine 331. Why is it 331? As we indicated earlier, it means that we have calculated this angle up to here, and mean that from 360 you just subtract 29, and then it gives us that angle which is there. Okay, so it gives us 331, which is the same as merely getting that same angle, which is 29, and then you will know that actually this one is oriented in the negative y-axis, which gives us negative 4.85 newtons. For C, also it is actually 215. For C, meaning that you have to calculate as well an angle starting from the positive x-axis until you reach where its force is, meaning that from here you go up to there. So it is base 35 plus 180, which gives us that angle. And you notice that actually is negative. So say 12 times sine 215, which is the same as merely by sine 35. And you know that actually see when you draw the triangle, it's oriented in the negative y direction, y prime direction, and then it gives us negative 88 newtons, negative 6.88 newtons. Similarly, for force D, you notice that force D to be 90 degrees, so it will be 6 times sine 90, and sine 90 you know is 1, which gives us exactly 60 newtons. For force E, which is actually 9 times sine 180, which is actually 0. Because 180 is 0. Sine 180 is actually 0. And therefore, because that this is the force component that we get, which is 0 newtons. And so here we have learned basic concepts of resolving forces in the x as well as the y components. And so now, after you have found each of these component forces, you need to sum them up. And therefore, we are saying sum all the forces in the x direction. That's all the component forces, you sum them up. And when you sum them up, you find that you get negative 4.21 newtons. Then as well as summing all the forces in the y direction, which means all the component forces in the y direction, you sum them, and you get negative 1.92 newtons. So for you to calculate the resultant, you need to define. Remember, we found that the resulting force in the x-axis, when you added all the components, it gave us negative 4.21, and therefore the force will be along the x-axis in the negative direction. As well as we found that the force, after adding all the forces in the y direction, we found 1.92, which is in the negative direction. Therefore, it will go that way. Therefore, for us to find the resulting force, or the resultant force, we can merely use Pythagorean theorem, square 4.21 as well as 1.92 squared, and we get 4.63 newtons. For us to get to define, remember, said a force, we cannot merely define it by the magnitude alone. Since it's a vector quantity, we also need to find the direction. Therefore, this is the direction which we can find by using tan theta is equal to 1.92, which is the opposite angle side here, divided by 4.21, which is the adjacent side here to the angle, which gives us 0.456. And therefore, when you get the inverse of this, you note that you get actually 24.5 degrees, which is above the negative x-axis. And so this is merely a basic concept that we have developed in resolving forces in two components. This is a very important topic because if we do not grasp these concepts, it means that more complex problems might be difficult for us to handle. And so I hope you have enjoyed the lesson for today, and I hope you subscribe to my YouTube so that you can continue getting these free lessons, which are very important for your future benefit, especially as you are studying physics, which might be incorporated to other courses you are doing. Might not be fixed, but as you know, physics at A level is a prerequisite for all science-based studies. And therefore, I hope you have enjoyed. We'll meet again in the coming lessons. I thank you.